Okay. Before we begin day 7 notes, those of you that are using a graphing calculator, this is going to be a short video just to get you acquainted with all the keystrokes that we'll talk about. So to enter data on our calculator, everything is going to be under stats. So when you click stats, the first thing we need to do is edit. So we're going to press edit and press enter in the bottom right, and it's going to bring us to multiple lists. So what we're going to do is make sure, so notice I have data here. So what I'm going to do is I'm going to arrow up and I'm going to press clear. Do not press delete, press clear over here, and then press enter in the bottom right, and it's going to clear our data. So what we're going to do is I'm just going to enter some random numbers in. So we'll go 1, 2, 3. So I'm just pressing the number and enter. 4, 5, 6, enter. And I'm going to enter L2, which is like my Y values. So again, I'm just going to make up numbers. We'll go backwards. 7, 8, 9, 10, 11, 2. Okay? Really important to notice is that we have the same amount of points. So notice I have 6 total coordinates. This is like the point 1, 7, 2, 8, 3, 9, 4, 10, 5, 11, 6, 2. Okay? Again, to clear out data at any time, you just press the clear button and press enter. Okay? So what we're going to do now is one thing we have to do on our calculator. So I'm just going to press second quit. It's going to bring me back to my home screen. When we run one variable stats, I'm going to press stat, and then we're going to, again, notice our data is an edit, but I'm going to press stat, and I'm going to go over to calc. And there's all different types of regression to run. What we're going to run right now is linear regression. So you're going to arrow down to number 4, and you're going to press enter. And what it's going to do is it's going to ask you where the X and Y values are from. Calculators may look a little different, and that's okay, but we always want to keep it L1 and L2. Meaning my X values are coming from L1, list 1, and my Y values are coming from list 2. And what we're going to do is scroll down till you get to calculate. Again, some calculators may have different amounts of values right here. That's okay. Just keep scrolling down until you get to calculate and press enter, which is in the bottom right. And here we have our linear regression equation. So what's really nice about this is we give y equals ax plus b, which is like y equals mx. A, also known as my slope, is negative 0.43. We'd always round to the nearest hundredth. B is 9.33, and then we have R values here, and we're always going to worry about the R value at the bottom, the correlation coefficient. Now, I'm guessing many of your calculators do not have this value, and that's okay. I'm going to show you how to get it. It's a one-time setup, so I'm going to press second quit, and what I'm going to do on the left-hand side of my calculator, at the very bottom, is this catalog button, and we're going to press second catalog. And what you're going to see at the top is all these different commands that our calculator does. And we're going to scroll down to the D's. And we're going to scroll down until we see diagnostic on. And so what I'm going to do, notice it's highlighted. I'm going to press enter. Okay, I'm going to press it one more time, and then you're going to see the word done. Okay, that means you turn diagnostic on. We only have to do this once. The only other time you would do this is if you replace the batteries on your calculator or recharged it. So again, to ensure that you have an R value, because I'm assuming some of you do not, we're now going to press stat, calc. We're going to press number 4, or you could scroll down, press calculate again, and you should have now the R value show up if it did not show up before. Okay, so as we move through this, again, everything is under our stat button. Edit, so maybe what we will do is for the next set of data, as we move through the notes for day 7, you're going to have to clear this data out. So I'm going to arrow up. Again, I'm going to press clear. Okay, I'm going to arrow right, arrow highlight L2, press clear. Okay, and now my calculator is ready for day 7 notes. So again, this short video just explains how to enter data. Once we have data entered in L1 and L2, we then use the stat button under calculate. And again, right now, we're going to choose linear regression number 4. Okay? And now we're going to transition to the day 7 notes. Hello, welcome to day 7. So these notes are going to walk us through how to describe and interpret data using linear regression. So linear regression is a measure to help us understand to what extent there's a linear relationship between two variables. And it's the exact calculation of the most accurate line of best fit. So previously we estimated the line of best fit, and now we have the exact calculation, and students are going to use either their graphing calculator or Desmos. This video is going to walk us through how to use a graphing calculator for linear regression. And once we have our equation, we're going to do two things with it. It's going to help us describe the trend of the data and interpret the data. So to describe the trend of the data, we're going to do two things. We're going to look at the scatter plot, which we'll watch a short video on how to do that on your graphing calculator, and we're going to use the correlation coefficient R, which is going to help us describe the correlation. And our calculator is going to give us an exact R value. It's going to be between -1 and 1. Okay? And so when we interpret it, we're going to use the following guidelines. So if it falls between -0.8 and +0.8, so we're going to make this -0.8. Okay, if it's in the middle, it's 0, there's no correlation. So anything between 0 and +0.8, we would describe it as weak positive correlation, versus 0 to -0.8, again, we would use the word weak, but it's going to be a negative correlation. Okay, and then anything between 0.8 and 1, or -0.8 and -1, is when we're going to switch over to a strong positive correlation, meaning there's a positive slope, or a strong negative. And this explains to what extent our data is linear, okay? The other thing we're going to do is we're going to interpret data. So to interpret data, we're going to use our line of best fit, which again, we're going to show you how to do it. And we're going to make predictions by using interpolation, which is predicting data inside the given data set, or extrapolation, which is the term we use for predicting data outside of the given data set. Okay? And so here we have an example which is going to help us practice describing and interpreting data. So the table below shows the total sales from women's clothing stores in the United States from 1997 to 2002. Make a scatter plot of the data and describe the correlation of the data. So the first thing we're going to do is we're going to adjust our years. So whenever we give you a year, we're going to cross this off and make it year 0. 1998 is going to be year 1, and this helps us because when we get our y-intercept value, we're not going to have a y-intercept value of year 0. It's way more accurate if we adjust these numbers starting at 0. Okay, and year is going to be our x, sale is going to be our y. X is the same thing when we enter our data. We're going to enter it into L1. Y, we're going to enter it into L2. In this video, I'm going to explain how to look at a scatter plot of data. So this data is going to be taken from our first example on our day 7 note. So in L1 and L2, I entered L1, all my x values, and L2, all my y values. So these are corresponding points, 0, comma 27.9, 1, comma 28.7, etc. Okay, so we think this data may be linear, but we can always look at a scatter plot to determine if it is. So to access our graph, we're still going to be using the y equals button. Now notice I have an equation here, so I'm going to clear it out, and I want all my y1s or all my y values to be cleared. And what we're going to do is we're going to go up here and work with our plot. So notice I'm going to turn on plot 1 by pressing enter. But I don't know what plot it's going to display. So what I'm going to do is I'm going to press second, y equals, and it's going to bring us to my stat plots. And let's worry about number 1. So while 1 is highlighted, I'm going to press enter. And we need to tell it what type of plot do we want. So it's on, which is great. And there's all these different types of plots, okay, which we'll eventually get to, but we're going to deal with the first one, which is a scatter plot, so keep that highlighted. You'll notice my X list is going to be from L1, which should sound familiar, and my Y list is from L2, which again, that comes from here. Again, X from L1 and L2, okay, so again, I'm back in my stat plot. It's on, okay. And then what I'm going to do is to graph my data from L1 and L2, I'm going to use the zoom feature. So I'm going to press zoom, which is the middle button, and I'm going to zoom, or I'm going to scroll down until we see zoom stat, meaning we want to graph statistics. So then I'm going to press enter. And what we have here is a scatter plot of our data. And when I look at this data, I see a line. Okay, so that tells me I will use linear regression. It's not perfect. Raw data is never perfect, or very unlikely to be perfect, okay? So again, as a refresher, if I wanted to then run linear regression, because I know linear regression is correct because the data is in a line, I'm going to use the stat button. Again, my data is in L1 or L2, which is great. So then I'm going to go down here to linear regression, highlight it, press enter, which is the bottom right, arrow down. It's going to run it. And so I have the line of best fit for that data. So my M, or my A value, is 1.36. My initial value, my B value, is 27.72. My correlation coefficient, my R value, which is 0.99, because again, I would round to the nearest hundredth, would be 0.99, which tells me I have a strong positive correlation. So now that we have our linear regression equation, we now can interpret and write our line of best fit. So we said A was 1.36, so our line of best fit is y equals, again, A is our slope, so 1.36x plus our y-intercept of 27.72. Okay, again, remember our B value comes from the B value output, my y-intercept, and my slope, also known as A in linear regression, is our A value. Okay, again, slope, y-intercept. Okay, we will never use the r squared value in Algebra 1. We are going to focus on the r value. So again, r equals, when I round correctly, 0.99. So if I go up to the chart at the top, 0.99 is like right here where I just marked in red. And so that indicates it's really close to 1, which tells us it's a strong positive correlation, which means my data is almost perfectly linear. It's not exactly, but it's almost there. So when we interpret this, we would then say it's a strong positive correlation. Okay. So again, this walks through the video. The video walks through how to enter data, adjust your stat plot, make a scatter plot to ensure it's linear, and then perform regression to ensure that we get our line of best fit. Again, linear regression gives us our exact line of best fit. We do not have to estimate anymore. Okay. So, example 1 says make a scatter plot of the data on your calculator. And notice we have this data of tall buildings in the United States. So we have different buildings, Sears Tower, Chicago. Obviously, we know it's now called the Willis Tower. And we have stories and the height in meters. So we're always going to make the first variable we see. If it doesn't tell us X and Y, we're going to make this L1 and L2. So what I want you to do, and you have to get comfortable doing this, is I want you to enter this data in L1 and L2 on your calculator, okay, and run linear regression. So what we're going to do, you can make a scatter plot. You can check it if you want to make sure it's linear. And then step B, using your calculator, I want you to find the line of best fit. So unpause the video when you are ready to check your answers. Please try this on your own. Okay, so when we ran this data, we should get y equals 2.59x plus 124.74 as our line of best fit. The R value is 0.88. The second step is we're always going to interpret it. The first part is it's strong or weak. So 0.88, again, I'm going to scroll over here. 0.88 is over still in the green section. And so that tells me I'm going to choose strong. And it's a positive number, so we have strong positive correlation. Now the next part is, now that we have our line of best fit, how does it help us? And again, this helps us make predictions. And so what we're going to do is we're going to predict the height of a building that has 80 stories. So 80 stories is my X. Again, over here, stories is X. Okay. And we're going to make a prediction what the height would be using the line of best fit. So you cannot use the table of values. Now that we have a line of best fit, we're going to say y equals 2.59. Instead of X, I'm going to replace it with an 80. And when I calculate that, I get 331.94 meters. Okay. So we predict using our line of best fit, 80 stories, an 80-story building is 331.94 meters. Okay. Now, when we make this prediction, we can then classify it either as interpolation or extrapolation, and that's looking at our given data set. So over here in the given data set, I see that my minimum is 55 and my maximum X value is 110. And so does 80 fall within 55 and 110? The answer is yes. So this is an example of interpolation because I'm predicting a value that falls within the given data set. Okay, so what I want you to do is I want you to pause the video and I want you to try to calculate part A, finding an equation that models the student's GPA as a function of hours of TV watched. So the table shows the number of hours of TV a week 10 students watched and their GPA. So again, hours of TV watched and our GPA. L1 is going to be our top value, also known as our X, our input. L2 is going to be my output, which is Y. And I want you to try, pause the video, and find the line of best fit. Okay. So using linear regression, you should have been able to write your line of best fit, which is Y equals negative 0.05x plus 3.84. And identify the correlation coefficient of negative 0.63, which tells us we have a weak negative correlation. So C and D we're going to work through. So examples, or part C says, using your equation, predict the GPA if a student watches 17 hours of TV. So remember, once we have our line of best fit right here, we have to use it to make predictions. And so 17 hours of TV means when X equals 17. So if I say Y equals, again, I'm using the line of best fit, I get an output of 2.99. So again, I'm using the line of best fit to say, oh, what happens if I watch 17 hours? Oh, then your predicted GPA is 2.99. Now, is this an example of interpolation or extrapolation? Now let's look at our values. My X values over here in the table of values, my minimum is 4 and my maximum is 25 and 17 falls within it. So it's an example of interpolation. Now we could also use the line of best fit to predict our X value. So here it says, using your equation, predict the hours of TV watched, so that's my X, if the GPA is 3.5. So I'm going to do this work down here. Okay, so my Y value is 3.5, and I want to know what's my X value. Okay, so we can use a series of inverse operations. And when we divide both sides by 0.05, we get x equals 6.8. Okay, so it says using your equation, predict the hours of TV watched. So we're making a prediction. 6 hours of TV watched if the GPA is 3.5. So again, we're using our line of best fit to make predictions, either predicting X, which was our hours of TV, or our GPA. Okay. Now the next piece is interpreting, and this is really important. So we get our line of best fit. What does it mean? Okay. And so we're going to go back and use what we know about our slope. So it says, what does the slope represent? So as a reminder, slope is change in y over change in x. And we have our number, negative 0.05. So remember, that's my slope. And I'm going to make my denominator 1. The other really important piece about this is to look at our units. So for y, my units are GPA. And for x, we're talking about hours of TV. Okay, so what does the slope represent? Well, let's literally interpret this. So what it's saying is the GPA decreases, because it's negative, 0.05 per, which is the division part, per 1 hour of TV. Okay, again, let's break this down. In my numerator, the GPA decreases 0.05. That's why it's a negative 0.05 per comes from the division bar. Okay, and then we're going to look what's in our denominator, 1 hour of TV. Okay, and so we've interpreted the slope. Again, the slope represents that our GPA is decreasing 0.05 per every 1 hour of TV watched. Okay. What about the y-intercept? So the y-intercept, remember, so that's 3.84. So we're really talking about what does 0.3.84 mean? Okay. Again, we're going to use our units. 0 is hours of TV watched. 3.84 is y, which is my GPA. So we're going to say the GPA of someone who watched 0 hours of TV. Okay. Again, X is 0 hours of TV. And Y is 3.84, which is the GPA. So you could also say, if you watch 0 hours of TV, you would predict a GPA of 3.84. Okay. Next, according to your model, could a student earn a 4.0 GPA? And I want you to think about that. What do you think?